So this is another approach on how to find the fractional distance of a line segment that is on the coordinate plane. Okay, you may have seen our previous example of taking, the 2 points and the line segment and then drawing the right triangle to count the lengths along the x and y axis. And this, what we're going to do here is actually separate, because we're going to take the y-axis, and instead of it looking at it on the graph vertically, we're going to take it and put it horizontally. So we have both the number lines representing the x-axis and the number lines representing the y-axis horizontally. Okay? Now, this is the same problem if you watch the previous video, but this time I'm using the 2 individual number lines. So we want to determine the coordinate of point P that happens to be 2/5 the length of line segment GH from point G. Okay, so you'll notice here that G has a coordinate of -4, -6, and H is 6, 3. Okay, so if you remember, we write coordinates x, y. Okay, so my 2 x values are -4 and 6. So I drew a number line that starts at -4 with G and ends with 6 at H. Okay, so -4 and 6 represent my 2 x values. Then I did the same exact thing for my y values. G is at -6, which is here, and H's y value is at +3. So that's how I knew where my number line should start and end. It was strictly from my coordinates given in my question. Okay, now this next part is exactly the same. It is we need to multiply the length of each segment by the fractional distance that's being asked. So you'll notice how from -4 to 6, that's 10 units. From -6 to 3 along the y-axis is 9 units. So this step here is the same. I'm going to multiply 10 over 1 times 2/5, and I get 4. And then I multiply 9 over 1 times 2/5, and I get 3 and 3/5. Okay? And again, these 2 numbers here represent 2/5 of the length along both the x and y axis. Okay. So once you find the total distance using the number lines and multiplying by the fraction, we can then do one of 2 things. We can either count right along the number line, and we're starting at G, so G is along the x-axis. So 4 is the x, the length, the number of units along the x-axis. The 3 and 3/5 is the length along the number of units on the y-axis, both starting from point G. So 1, 2, 3, 4 units from G is 0. And from -6, if I count 1, 2, 3, and then 3/5, where I end up is at -2 and 2/5. And there's a separate video on how to count on fractions. So if you're counting. But the other option besides counting is we can add or subtract. In this case, we're going to add both because we're going from -4 to +6. So we're moving in a positive direction in both cases on the x and y axis. So going from G to H, I'm getting bigger. The numbers are getting bigger. It's becoming more positive. So that's how I know to add both of my fractional lengths to my coordinate. And my final answer, of course, is 0, -2 2/5. Now let's take a look at another example where you might have to subtract. So question number 2, and I apologize for the misprint here and how it's formatted, but this will show you how in one instance we're going to add to our coordinate, and our second option we're going to subtract. So we want to find 2/3 along line segment CP starting at point C. Okay, so I have my x values here and my y values here. So along my y, if I draw my number line, my first, because we're starting at C, so C starts at 4, +4, and goes to -2. Okay, and P is at -2. My x value, C is at -6, and P is at +6. So when you notice along the x-axis, we go from negative to positive. So when we are calculating our final coordinate, we're going to add our fractional distance. But along our y-axis, you notice C is at +4 and P is at -2. So in this case, we're going to need to subtract our fractional distance. So again, always need that total length. So from -2 to 4, that's 6 units. And from C to P on our x-axis, that's 12 units. Okay, so in both cases, I need to multiply both lengths, 12 and 6, by 2/3. And we're lucky in this sense because in both cases we're going to get whole numbers. Okay. So the fractional distance along the x-axis is 3 units from point C. So 1, 2, 3, -7, I'm sorry, -5, -4. So this gives me -3. And along our y-axis, my fractional distance is represented 4 units from point C. So 1, 2, 3, 4. That brings me to 0. So my final answer is going to be -3, 0. And that's going to be so point A would be at -3, 0 to represent my 2/3 distance from point C. Now, that's counting around on the number line. If I took the coordinate C, which I know to be -6, 4, okay? Now remember, on our x-axis, we're going from negative to positive from C to P. So I am going to add my 3 units. But again, for my y value, I'm going from 4, C's at 4 and P's at -2. So that's negative. So I actually have to subtract my 4 units. So that's how I get -3, 0 if you were adding and subtracting. Okay, so whether you add or subtract these fractional units depends on whether from your starting point to your end point is becoming positive or if it's becoming negative.